Well, hi everyone, I'm back again, and today we're doing some kitchen chemistry. And our kitchen chemistry today is going to be with red cabbage. It's called the red cabbage pH test. And what we're going to do is we're going to look at and talk a little bit about pH and what acids and bases are. So, pH is a test that we run on solutions to determine whether they're an acid or a base. Now, pH deals with the hydrogen that is the percent of hydrogen in a solution or in a substance. And so that's how we use it to determine acids and bases. So everything in the world is made up of molecules. And molecules are bound together. And there are times when you mix things together where the bonds will break and reorganize. So this right here is a very simple molecular structure for plain old water. You've heard it called H2O because they have 2 hydrogen and 1 oxygen. Now, when we combine things at times, sometimes the bonds will break and the hydrogen will come off and it could release hydrogen and move to another part of the solution. Or some substances steal hydrogen from other substances. So when we talk about pH, we're talking about that proportion of hydrogen in a substance. They can these molecular structures can release hydrogen, or they can steal hydrogen. So different solutions do different, or different substances do different things. So some substances release their hydrogen when they are mixed, and those particular substances are acids. They release the hydrogen. Okay, and then there are some substances that steal or take in extra hydrogen, and those would be bases. Bases steal hydrogen at an unbalanced rate. Then we have some substances that give and take hydrogen, but they do it in a balanced way so that everything stays nice and balanced, and those are called neutrals. So the pH test allows us to tell whether something is an acid releasing hydrogen, or it is a base which is stealing more hydrogen, or it is a neutral where it gives and takes of hydrogen, the hydrogen atom balanced in an equal way of give and take. So we're going to use red cabbage. Red cabbage is the color red because it has a mineral in it called anthocyanin, and this gives it the red color. Now that color interacts with acids, bases, and neutrals in different ways, and we can determine whether something's an acid or base or neutral based on the color that it turns. Okay. Now pH is the testing or how we measure that amount of hydrogen, and it goes from about 0 to 14 in that range there. So we have a scale. We talk about scales a lot in science, but the pH scale goes, if the pH number is below 7, that means it is an acid. So if we know that if something has a pH below 7, we know it's an acid. If it has a pH over 7, higher than 7, then we know that it is a base. If it has a pH of 7 exactly, we know that it is a neutral because it is balanced there. Now, lots of things in our kitchen are acids and bases. We use them a lot for cooking. Acids you get a lot, some very naturally through like fruits and vegetables. Lemons, tomatoes, even pineapple has some acid, and sometimes you can taste them. If you eat a whole lot, you can get little acid sores in your mouth, or your stomach might hurt if you eat too much because they have a lot of acid in them. We also use bases in cooking and also in cleaning supplies. So today what we're going to do is we're going to test some solutions that I've gathered from the kitchen, and we're going to see whether or not they're an acid or a base. And the way we know that is by the changing of the color. So we got some red cabbage juice. Now the way that I got the red cabbage juice was very easy. You cannot buy red cabbage juice in the store. You have to make it yourself. But I bought a head of red cabbage, and then I cut it up and I put it in a pot, and then I covered the red cabbage with water, and then I boiled the red cabbage. And you boil the red cabbage about 5 to 8 minutes, or until the water that you put in it turns this dark purple color. Then you drain the water off of it, and I saved it and put it in a bottle. And then you can enjoy by eating the nice cabbage. And I love cabbage, so this was a really nice dinner treat for me to have red cabbage for dinner. So we don't need the cabbage, but I do keep the cabbage juice. Now I will warn you, when you cook the cabbage, that it has a very pungent smell, and some people don't like it, so you know. And the juice also has that smell, so if you want to keep the juice around, you might want to keep a cap on it because it does have quite a little odor. So what I do is I take this red cabbage juice. Now, like I said, it has that chemical in it that will change color when it's exposed to an acid or a base. So I'm just putting a little bit in each one of my, this is a paint palette. You do not want to put any chemicals into something that you're going to eat off of later or cook with. So please do not use your cups that you're going to be drinking water out of later, or something that you would be baking with. Please make sure that you're using something that you're not going to be cooking with. This is a paint palette, and so all it ever goes in it is some of my science stuff or maybe paint. So we're not going to be eating out of it. But clear plastic cups would work just fine. Okay, so I put my cabbage juice in there. And now what we're going to do is we're going to test the different solutions that I have around me, or different substances I have around me, so that we can determine whether they're acids or bases based on the color. So if the red cabbage juice changes to a blue or a green, we know that we are dealing with a base. And that means its pH is higher than 7. Okay? If the solution changes to a red or a pink, we know that we're dealing with an acid, and acids have a pH of less than 7. If the cabbage juice remains purple, then we know that it is a neutral, which means that it is staying, it has a pH of 7. All right? So we're going to be looking for color changes in our palette here, and I have 6 substances that I've picked, and we're going to test them and see which ones are acids and which ones are bases, and if there is a neutral in here. Okay, so I'm going to start off with plain old water. This just came out of my tap, so I'm going to take water, and I'm going to pour some in my first cup there, and we're going to take a look at it and see if we get a color change of any kind. Okay, I'm going to pour a little more in there. All right, do we see a color change? Well, I only see purple, so that means that water is a neutral. It didn't change color in any way. Maybe the purple got a little lighter only because I added more water, but it stayed the same. All right, so now let's take another substance that I have. Let's take some vinegar. Okay, we use vinegar. I use vinegar in salad dressing, and I use vinegar to cook. So I'm going to take some vinegar, and I'm going to pour it in this second. All right, now I'm going to keep pouring a little more. Do we see a color change in that one? Well, yes, we see that it's turned red, hasn't it? And we know that red means it's an acid. So that means that its pH is low, and it is an acid, and this in particular is an acetic acid, and we use it for cooking. Now I will tell you that if you try to taste it, it doesn't taste good, and it has a strong smell to it. So we can see that it turned red, so we know that it is an acid. All right? Okay, so now I'm going to go on this side, and I have baking soda, which is in my baking cabinet, and I'm going to put a little bit of baking soda in my cup here. Oops. And I'm going to break it and stir it. Oh boy, I can see a nice color change there. What color do we see? Well, I see blue. And blue means that it is a base. So we know that its pH is higher than 7 because it turned blue. So now I have a neutral, I have an acid, and I have a base. All right, let's try my next thing. I have lemon juice. And I'm going to shake it up because sometimes the lemon juice, all the lemon stuff stays in the bottom. Okay, so I got lemon juice. I'm going to take it and I'm going to pour it in this next one. I'm not going to use a whole lot. Oh boy. I'm going to just put a little more in there. Okay. So I see another color change. So we see that red color, kind of a pinkish red. So we know that this is an acid, which means that its pH is below 7. And I actually know that lemons are a citric acid, which is a natural acid that occurs in a lot of citric fruits. So we can just prove that with this purple red cabbage juice that this is an acid. Okay. Now I'm going to pull my next item. This is a cleaning product. It's a clear ammonia. And we're going to test it over here and see if it is an acid, a base, or a neutral. Now, while I'm putting it in my syringe here, I want you to think, what do you think it's going to be? Do you think it's going to be an acid? Do you think it's going to be a base? Or do you think it's going to be a neutral? Now, I'm just using a little medicine syringe so that I can pour it in there nice without making a big mess. But if I were to use this, then I would never put medicine in it. I would just use it as a science tool from now on. Okay, so I'm going to put it in there. Oh boy, can you see that color change right now, huh? And I see the color green. Is that what you guys see? Well, if it's green, we know that it is a base. And a base has a very high pH. In fact, I can even tell by the color change here. This was a base, it was blue. This is a base, it was green. That actually this base has a higher pH than the baking soda. So we can even tell because the bases turn blue or green that if it's green, it's going to have a higher pH. If it is blue, it's going to have a little lower, but it's still going to be above 7. Okay, so these are both bases. All right, now, my last one I'm going to do is, this is sparkling water, which is carbonated water. So there's carbon in here like a soda, but I liked it because it's clear. You can hear the carbonation in there. And I'm going to pour it in this last one that I have here. Okay. And we're going to take a look at it. All right. Now, let's take a look at that color change. Now, this still looks purple to me, but let's look at the water. That's a lighter purple, and this is a darker purple, almost turning into that pink. So I can tell that this particular substance is an acid. It is a very light acid. That means it doesn't have a whole lot in it, but there is a little carbonic acid in this particular substance, only because you can see that it's a little darker than our neutral we have here. So here's a neutral. This is plain water. Then we have our two bases. This was baking soda, turned a nice blue. And here we had our ammonia. This is the really strong, dark green, a really high pH. Then we have our three bases. Okay, so we had our, I think we used our vinegar here, which is acetic acid. Then we used our our lemon juice here, which is the citric acid. And then we used our sparkling water here, which had a little carbonic acid. So I can now tell what's an acid and what's a base based upon my red cabbage juice and pH. So a little recap. pH talks about the proportion of hydrogen in the substance. The higher the pH is, we have above 7 is a base, and bases will turn blue or green. They release, or bases, steal hydrogen. Then we have acids. Acids have a pH of less than 7, and acids release hydrogen. And they turn red or pink. And neutrals have a pH of 7, and they give and take a hydrogen equally, and so the color remains purple. So I hope you get to do some of this at home, do a little kitchen chemistry. Remember a couple things. One, do not use chemicals in anything you're going to be eating out of later or baking or cooking with. And never mix any of the chemicals together, because sometimes when chemicals mix together, they have a reaction and it is dangerous. So anytime you're doing any kitchen chemistry, make sure that you have an adult present with you as you're doing that. So I'm anxious to see what you guys test and how your experiment turns out. So if you want to send me a picture or a video or a report on what you have created, please do so. Make sure that you keep a log and tell me what substances you added to the red cabbage juice, what color the substance changed to or turned to, and what does that mean? What did that mean? So remember, my email is m as in Margie Suter, Suder, at k12.wv.us. So I look forward to our next time. See ya.